Yeah, right now. Yeah.
Okay. One second. My whiteboard is not working.
I think you're not using this. um,
Uh, which one?
No, no, no. Sorry, my bad. My
No, something wrong. Today I tried thought of changing the display. One second. Can you see the whiteboard?
Yeah.
Yes, sir.
No, I'll stop sharing it. Uh, okay, got it. Okay. So in the first day, we have seen that same example, like I am browsing the internet. Okay, google.com. Okay. For that, in between, what are all the things happening? This is what we have seen in the first class, for in the trial classes, first three classes. So now we are going into a refined approach. Okay. For example, here the same case we are going to see it in a different view. Okay. Here Harish is there. Okay, Harish want to send a file to Sai. Okay,
Okay.
the Word document.
Okay.
Sai is in St. Louis and Harish is in Boston. Okay,
Okay.
okay. Basically, we are going to move a Word file from here to here. Okay, how we are the same approach. First, what we have done it, we have connected with the Wi-Fi, then we connected with the AT&T gateway, then it goes to ISP, then it goes to public internet, and finally it reaches the google.com. So in networking world, they now that is kind of a storytelling, but we are actually coming into the actual theoretical part. How I said that the basic equation like E is equal to mc square Einstein equation, and the thing four parameters we have discussed. All those things are basic things. Similarly, for the networking world, if we want to move one file to another file or one application to another, one day sending data from one computer to another computer or retrieving data, it follows a layer approach, 7 layer approach. You might have heard about it, the OSI layer approach. Um, that is the layered approach. That is a standard approach we are following up throughout the organization, throughout the world. and all the vendor companies follow the layered approach. Why they have introduced this layer approaches? Because earlier, in back in old time, if you send a file from Mac OS to Windows OS, it was kind of a tough to open it. You can't use a pen drive with between Mac and Windows. The same thing happened in the old ways. Every vendor like Cisco, Juniper, everyone have their own protocols. When we are able to connect the Juniper router with the Cisco router, it was not working. So initially, all the operator, if I am going to launch a service, means the entire thing was in stuck up with only one vendor. So in order to avoid the dependency, all the vendors come up and form this OSI layered approach model. So everyone have to follow this layered approach model so that irrespective of the vendor equipment, irrespective of the application, irrespective of the device, you can happily communicate with one fellow to another fellow. So your laptop can communicate to a IoT device or sensor. Your laptop can communicate to the fridge, to another laptop, to another mobile, to TV as well. Okay, so let's see how the OSI layer up started. So this OSI layer, as I told, it consists of 7 layers now. Okay, let's start with the first layer is application layer, and then presentation layer, session layer, transport layer, network layer, data link layer, and finally physical layer. I know it is tough to remember it, but don't memorize it. You will understood it slowly. As always, we can incorporate with an analogy so that you will remember it forever. This is the basic OSI layer approach. Now how we are doing it. Okay, similar way, this side also. So I also follow that same application layer, uh, presentation layer, session layer, transport layer, network layer, data, and physical. Okay. First one, what application we are using? What application?
Browser.
No,
Ah, application or operating system.
no. I can consider your case. Only the actors are Harish and Sai. Your computer, my computer. Your
Okay.
word, there is your word.
Hmm.
The application is Word document,
That
right?
PDF. Good. Yeah, okay.
Word application you are using. So
Okay.
intention is Harish
Okay.
is sending a Word document to Sai. Sai
Okay.
will open it. So if Sai has to open the Word document, he needs a similar application, like
Hmm.
Word or a Google Sheet or something else which is compatible. So first thing, Harish, what he is doing is he is accessing an application. So if you want to access an application, you need to follow the certain type of procedures. Like for example, if you want to browse the internet, what application you are using? You are using a browser. Okay. So similarly, if you want to type some content, you are opening the word browser. So there comes the certain protocols in this one. So here what we will do whenever you are dealing with the files or applications or internet, you are dealing with certain protocols in this case. So basically what this application or layer will do is it allows you to access the applications. Before, obviously every stage has its authentication and verification. So application layer deals with it allows the users to access the application and ensures that before Harish send any Word document, it inform the other operator that you are going to get a Word document from Harish. Okay, so first thing, it is allowing to open the application. Second thing is you are sending the application or the Word document to him. So either what is the file transfer protocol you are using it or HTTP, the usual internet, you are sending it via internet. So you are using HTTP or HTTPS. Yes, for security. Okay. Uh, so, uh, uh, before everything is starts, so you are telling the other OSI layer side that you are going to receive an application layer level session in this one. Okay, so now we said it. So next one is the presentation layer. In presentation layer, what we are doing it, we are converting the data into presentable data. So Word document is whatever. Hi, how are you? That is the message Harish has typed in the Word document. Hi, how are you? Is a human readable yeah, language. So we need to convert it to a machine readable language. Will you agree that or not?
I agree. Yeah.
Okay, so we need to convert it to a machine readable language. What is the language it is? That is the, if it is a word, you are converting it to a doc or docx.
Okay. Okay.
That is the job of the presentation layer. Whatever is coming from the application layer, it converts it to machine readable language. That is called as the presentation layer. Like it presents the data to the bottom layers. How? By changing the format. If you are sending a picture, it will be JPEG, PNG, audio file, MP3, MP4, all those things we are keep following in that one. Okay. And also, apart from this, the presentation layer, what it will do compression, encryption also in this layer. Okay, so before sending any file, it try to squeeze the file, compress it so that it will be easy, make it small and send it into the transport medium. So it do the compression and also the encryption technique. Encryption technique, there are a lot of encryption algorithms is there. So we with the one we see in the Wi-Fi, WAP is there. Right? You saw that WAP-V2. If you look at your properties in your wireless modem, you can see that protocol. So we are using some encryption protocols as well as the compression product. Compression is compression MP3, MP4 is also one type of compression techniques only.
Okay, Sundar. Yeah.
Okay. Now we are good. So far we are done. Then the session layer. The name itself it implies that we are going to establish a session from here to. Actually, this is the session we are establishing it from here to here. Sorry. So in application layer, what are all the protocols involved? Sample HTTP, HTTPS, FTP, uh, simple mail transfer protocol, some TP. I don't need to remember it. It's all, if you are sending a file, if it uses FTP. If you are sending an SMS, it uses SMTP messages, all those things. So in the presentation layer, you saw doc, JPEG, JPG, MP4, MP3, all these things. Now in the session layer, now only we try to correspond, coordinate with the size computer. We are going to, it tells that I'm going to create one session.
Uh,
Yes.
so then is the presentation you said like The MP4 and MP3, those are protocols?
Uh, we can't say it is a protocol. It is a file format. Very good. File format.
Okay.
We should
But
treat it as
the
file format.
application level has protocol.
Protocols. Yes, of course. Very good.
Oh,
Yeah, that's keep changing. Don't expect everything has protocol in each and every layer. Okay, that's a
okay.
question at the right time. Okay, so in the session layer, what it will do, this layer is responsible to first it will kickstart the communication with size computer. So it create a session and maintain the session. Once the data is transfer, he sends a file, you opened it, then it close the connection. That is done by the session layer.
Okay.
Any questions in this one so far? Are we good?
Yeah,
Yeah,
we are.
good right
It
now.
is
Yeah.
a kind of virtual session only, no physical location. You are connecting it. You are informing him that I am going to maintain. It monitors duration of the day. It knows how when to close the session, so it closes the session. So these three fellows are called as okay application layer protocols.
Surendra, sorry to interrupt again. So
Yes.
the session layer, what you told is, when you are sending it, no, those three
Right.
that you said,
Uh,
right? Create, maintain, close. Okay.
Hello.
So whatever you are sending from one computer to another computer,
uh,
so everything is comes under this application protocol layer only, no? Create, maintain, close.
in what way you are asking, Harish?
Like for example, what we are seeing right now as an example is the Word document, no, that I'm
Uh,
sending from computer
Correct.
to this.
Uh,
So even for example, it is the same for any of the kind of files that I'm sending, right? From my computer to this computer,
yes.
like that
Uh,
sharing.
I will ask you back. So now you are browsing it. What type of data will be there? It is so it uses HTTP protocol. Obviously, a browser uses HTTP. And
Yeah.
if it goes to presentation, what will be the file?
If you
Or how it HTML,
HTML will be there.
HTML or JSON, whatever it is.
Yeah, yeah, yeah,
Clear, Harish?
yeah. Yeah, yeah. Oh, it's fine for me now. Yeah.
Sai, do you have any questions, Sai?
No, no.
Okay. Okay, so once and now slowly we are at first three layers. We don't have any control as a network engineer. It is not our business. It's not our scope of work. We are not going to work on these three players. But still, why we want to learn is we should know what is happening above our head, so that we will adjust ourselves to this procedure. So first three things, these are all virtually. It's all software things only. So the software engineer take care of everything. So it is not your job that making the doc file, do the encryption, description. Everything is kind of virtual only. No physical devices involved in this one. Will you agree that or not?
Yeah,
It's all programming. So after you started a session, now comes the transport. The name itself says you are transporting transporting something from one end to another end. Okay. So while transporting, what is the important thing? If I want to send a parcel from one location to another location, what is your expectation? One, it should be reach the location safely. Even in case if it get lost, I should get notified that the parcel didn't reach to the destination. So this is the minimum thing and fastest delivery. Will you or anything is there when you are sending giving a parcel to UPS? What else you will expect from this?
that's it. Security.
Very good security. Sorry. Okay, so same thing. First one is you are sending the parcel. So you are giving the parcel to. So you need first one is reliable. Okay, if something happened or a packet is delivered, you requested an acknowledgement. Okay, I should know whether the packet reached the destination or not. Okay, you expect that acknowledgement. Third one is speed. Fourth one is your security. Okay, so these four things are going to happen in the transport layer. So to do all the things, there are multiple protocols are there in the transport layer things. Okay, what is protocol?
Excuse, so what is reliable means?
Reliable, safely it reaches the location.
Okay,
And
safe.
so, okay, I will give you an example. There, if you want to give a courier company, who will a local guy or a UPS guy?
UPS.
UPS.
Ah, that's the one. So why? Because you believe UPS will deliver it safely.
Okay.
Okay.
Okay, what is protocol? Day one.
So protocol are the
Harish.
like rules
Very good. Rules. Rules or guidelines for whom?
to
Um,
who are doing the work.
for
No.
the web application,
What
like how
happened?
it, the protocols are set of steps that it needs to follow to send this from this to that end, right?
Ah, it is a basically protocol is a rules or guidelines or a program code to send information from one end to another end. You should follow that rules and guidelines. Then only you can able to send the information. So okay, that is
Okay.
protocol. Okay, so here it comes the protocols like TCP, UDP, and all. Mostly these two protocols were widely used across the globe. So TCP is nothing but transmission control protocol. So UDP is the data packet. I'm sorry, I missed it. Okay, no worries. I will keep it in the document. Okay, the main difference between TCP and UDP is TCP is reliable. It will acknowledge you, but speed is slow. Okay, but TCP is secured. UDP is actually it is very speed, but it is not reliable. It won't give you acknowledgement, but still it is secure. Which one we will prefer now?
Can you say it back again?
Okay, TCP. TCP is it is actually reliable. It used to acknowledge. That means it confirm you. UDP is it is speed. Okay. Which one you will prefer now?
I prefer TCP.
Okay, then why they invented UDP? Any guesses?
Inverted UDP. You said inverted UDP.
Maybe they innovated UDP. Everyone
Okay.
can follow TCP. No, why not UDP?
I think we will use both of them.
There is a situation. I will tell you. If you want a reliable communication, like you are talking to people, uh, um, you are sending a files to them safely in this area, then you will go for a TCP communications. But UDP is all the less priority application, less priority usage, or they all use the UDP packets. Because not all the packets in the internet are high priority packets. Another best example is email. What is the difference if you are receiving the email after 1 minute or 2 minutes? That doesn't bother you, right? But if you are watching the movie, you want continuous stream of scenes, and the streaming should be continuous and flawless, right? So that you will get a very good user experience. But in UDP cases, like getting an SMS, getting an email messages, or getting a status messages, like if you are opening the door, the message will come to your to your mobile devices. These pop-up notification, these doesn't require a reliable communication or acknowledgement. Anyway, it will be delivered. That is the ultimate aim. Maybe after 5 milliseconds, 10 milliseconds, so that is the case here. So will you okay with that? So all the email applications, SMS, pop notification, these kind of less priority of the applications or data which can wait. There is no urgent to get the data immediately. Those kind of traffics are sent via UDP.
Like
Okay.
movies and
Okay. So it depends on the situation.
Yes, situation and
Yeah.
application
Yeah. Yeah.
by default. Uh,
Mm.
you know, today you are getting 10 mails, but you are not checking consistently your mailbox, right? If I send a mail, okay, I'm not going to inform you that I am sending a mail, but I just sent a mail. It will
Mm.
come to your inbox. It will take its own sweet time, but that doesn't bother. Anyway, you are going to get the mail. Maybe a fraction of seconds there was a delay.
Mm.
But you are not desperately looking for that mail. But there are some situations. But still, you have to wait for it, and then it will take its own sweet time, and you get it, the information.
Yeah. There are seconds delay in
Yes.
the sending emails. Yeah. I noticed.
Yes. Okay, how why it is get TCP is getting delayed means, for example, two people are talking to each other. So first, this fellow sends a packet to him. Immediately, this fellow sends an acknowledgement packet. Okay, I received the packet. Then only the other fellow sends a second packet. First packet, second packet. Again, he will acknowledge it. Again, he will send the third one. It's kind of irritating because every time we have to wait for it. So they try to play another trick. Instead of sending one to one, what they have done is send one, two, then wait for this fellow. Okay, I received two packets. He confirmed two packets. Then again send two packets. Oh, I
oh, I
received
see.
only one packet. I lost one packet. Okay, okay. Here is the last packet. I'm sending it again.
Like it's the mails.
Not
Who's-
mails, your packets, all your data, or we can say data in the sense, if your data language is the everyone speaks that data is transmitting between devices, but we used to say packets or frames like that.
Okay. So data, how I didn't get the this example.
Okay, I'm talking about TCP, how TCP works.
Okay.
TCP work is so, yes, Harish sent it to you, Sai is here. First, one packet, Harish sent it to Sai. Sai receives the packet. He said, okay, I received your packet. Okay, then he sends the next packet. Okay, then in this fellow sends, I received it. Okay, acknowledge. Every time he acknowledges. If Harish didn't get the acknowledgement from Sai, then what it assumes, okay, something has gone wrong. The packet might be lost while going to Sai. So immediately what he will do, he retransmit the packet if he didn't get the acknowledgement. Got it?
So how it? So I have to acknowledge that again.
Yes, yes. You mean for every time you have to acknowledge it. Okay, I received the packet. I received the packet. I received. Send me the next. Send me the next.
Like,
Ah,
is it like a uh, s- sending the word to him, or I'm confused. Like,
not like Word document. Yeah. Okay. Very good. We will see that. For time being, you said it is a okay. Keep it like this Word document in your. For now, you keep it Word document. You send a Word document and to Harish. Harish said, "Okay, I received the Word document. Send me the text document." Okay. After getting acknowledgement to him, you are sending the another document. Same
uh,
way.
okay, I'm saying this. So it's how the TCP is working is like between two. What are those two? Like don't say Sai and Harish. Maybe
It may be any
those two.
device, any communication device.
Any communication devices. So they are, it was not seen like not by me or Harish done. It was done by the communication devices, right?
Yes, yes. You are not acknowledging him. You are not acknowledging.
Okay, okay, I'm
Ah,
confused.
okay.
Yeah.
Sorry, got it. A transport layer will acknowledge it. This layer's job is to acknowledge.
Okay,
Send it, wait for acknowledgement. Send the next packet. Acknowledge
okay,
it. If the
okay,
acknowledgement is not coming from you, then Harish assumes that okay, some the packet which I sent was lost. Okay, it will send it back to him.
okay.
Harish, okay?
I'm okay. Yeah, I understood actually.
Oh, okay. So you feel it is kind of irritating every time you send a packet, wait for acknowledgement, then you start the next packet. Do you feel that it's kind of irritating or delaying the process?
Yes, it is delaying. No?
What's you are silent?
I-
You will come
First
up with
time,
this different logic. Tell me that logic.
no, no, no. Like first time, if it is done, like after the acknowledgement, like only first file has been sent,
Ah,
then it's done, right?
ah. So you are sending
Why
1,000 files to him.
thousand files? Okay.
So every time you send one file, wait for acknowledgement, then send the second file. If you start
Oh,
in the morning, you will end up in the evening by sending all.
yeah, yeah.
So they introduced a concept called windowing. Windowing. What it will, instead of sending one and getting back acknowledgement one to one, they send at a given point of time, send five data, receive acknowledgement for all five data in one shot. Is it good?
Mm. Uh, can you instead of acknowledgement, no? Instead of acknowledgement,
No, no, no. Acknowledgement still it is there. So instead
okay.
of one to one, I'm sending five data, five word files to Sai. Sai send one acknowledgement. I received five files.
Yeah, this is
That's
good.
okay or not?
It is
Yeah,
okay.
yeah,
Okay. Yeah, it is okay. Yeah.
If Sai receives only three, he says, okay, I received only three. These are the three I received it. Just one acknowledgement for one reply. Instead of five acknowledgement replies, he is sending one. This is called as windowing. You can keep on increasing, keep on reducing. It is dynamic in nature. So how it will happen? I will give you the interesting story behind this. So for example, I started with the lowercase. Five is the minimum start. Okay. I send five. Harish send five. Sai sends one acknowledgement back. Slowly, the communication progressing. We witnessed that over a period of time, Sai said to Harish that, "Hey, I lost one word document here. Next thing, I lost two. I lost three. Okay, you keep losing the packets, and it is continuous over a period of time. Okay, then the machine says, okay, something is going on in the path. some robbers are there in between the road, so they are stealing the packets. No? So what it will do, cut it down to again switch back to one, send to one, wait for no one, wait for the acknowledgement. If then the success rate is high, then it slowly increase the window. Then go for 2, 3, 4, 5, 6, 7, 8, 9, 10 maximum. Once again, if it started experiencing packet loss, slowly it will bring it down. So that is the dynamic nature.
Hmm. Okay. Okay.
When it
That's
will happen in transmission path, that is in the network, if there are errors will be there. Errors means what? Noise. You are generating noise. Every device, every electronic device, apart from the actual signal, they used to generate the noise as well. So
okay.
whenever noise is there, error will be there. In another case also, if you bend the fiber closely, you will generate a noise, you will generate an error. Obviously, packets will get dropped.
No, no, what is noise?
And noise is the unwanted signal.
Okay.
Signal saying we are sending a power to the signal which contains a message information. But obviously, there will be some, along with the signal, there will be some unwanted signal portion is also there. It is getting added whenever it passes through every electronic devices. There will be a small noises added to the actual signal. That is unavoidable. We can reduce the noise, but it is there. It's a
Okay.
physics. Yes. Signal to noise ratio. You might have heard about it. SNR.
So, no.
Oh, okay, no, that is the thing. That is in physics, what we'll say signal to noise ratio. That is means what is your actual signal? So you are sending 100 signals. In that signal, 80 is your good signals, 20 are a noise. So your signal to noise ratio is sorry, 20 to 80, 20 by 80 is 1 by 4. So this is how every device has a SNR ratio. If I send 100 signals or 100 power, how out of that how much unwanted thing or noises are added into that. So that is called that signal to noise ratio. So I'm telling here because while traveling over a long distance, the signal loses its power. Because of that, it can't able to read the message. It can drop the packets due to congestion. The packets get dropped. Um, Here, I will give you one another example. So these two people are talking to each other. Forget about all the things we have discussed. Simple case. He is sending packets in a very high speed, but this device is a kind of a slow device. What will happen here? For example, he is sending in 50-kilometer speeds. He sends all the packets, but this fellow receives in 40-kilometer speed only. So
So
what will happen?
it have to reduce maybe
What will be the effect? What will happen if these two fellows are started talking each other? What will happen eventually?
he like some data might be missing.
Missing packet will be dropped. Yes, you know that yeah, for example, this is one lorry. Here there are a lot of coconuts are there. So usually what they will do, one person standing here, he will throw the coconut, and the person standing in there, he catches it and put it here. If he is speed, in this fellow is lazy, what will do? Coconuts
He'll
will fall
drop
down.
the yeah.
Uh, Fall down. They drop the coconuts. This fellow. No. So
Yeah.
same thing. It will be dropped here. If we will consider the reverse case, he is slow. He is fast. What will happen?
So he was seeking for the coconuts.
Yes.
No- Nothing
Ideally,
is
what will
dropped.
happen?
Nothing is dropped.
Nothing is dropped. Okay, perfect. But what is
Oh,
happening?
slow, slow.
slow. This fellow has to wait for it. He over a period of time, this fellow get irritated. Throw it fast. He will start yelling at this fellow, right? So
Yes.
this fellow has to wait for this guy. So what it will do? Actually, during every time the we have to generate a packet. For every second, we have to generate a packet, whether it is containing the data or not. So what it will do? It during that time it sends a dummy packets to its machine. Okay, in this time I didn't get any information from the opposite fellow. So the receiver inside your team unnecessarily have to process this empty packets also. So
So it's
during the
you are saying TCP only, right?
no, no, that's what I said. Don't forget about all the things, the TCP, ID. I'm talking about slowness. I'm talking about why we are introducing this window concept, send and receive acknowledgement.
Okay.
Why packets are getting dropped in the network.
Okay.
Uh, if there is no loss in the packet, then we don't need all these things, right? Will you agree that?
Yes, yes.
But it is impossible to maintain such a network. Lossless media, it is impossible. So the reason for losing the packet is one is physical limitation.
Physical limitation. Okay. Like how?
Okay, 1 second.
Okay.
Oh, okay. Okay, physical limitation is okay. You are sending a light. You are sending a power current. Okay, you are sending. You connected a battery and send the power in through a wire. Okay, the other end is connected to a LED bulb. If the LED bulb is connected after 100 meter, will that LED bulb will glow?
No.
Why?
The current will not pass till there.
Uh, if you are if you you are using a torch light, this torch light can you able to see if I'm in a flight, can I see your torch light in the earth?
No.
If you are using laser, probably.
But a light, I know this thing, but light is infinite, right?
The light is a, I agree what you are meaning. Light travels in a speed of 3 into 10 power 8
Yeah.
meter per second. That is speed. But you should have power, right? You should have, otherwise it become invisible.
Okay.
Agree that or not? No?
Yeah, yeah.
The same like sound waves also. If in person, if we are talking, maybe hardly 50 meter we can hear. After 100 meter, the sound will be so low. After 200 meter, we can't hear with bare hair. Yeah, yeah. So
Yeah.
that is the physical limitations. So everything has a limitation. That's a physical limitation. Second one is congestion. Congestion is what I example that coconut story. Third one is interference. This we will see it in the fiber optics. Why interference? Okay, there is a racetrack. There are races going on. All the cars are Ferrari cars. In between, one scooter is going on. What will happen? In a racetrack, there is a race going on. All the cars are
Yeah.
Ferrari cars. Suddenly, one scooter is also in the race. What will happen?
It will fly. It will push them outside
Uh,
because of air. What
so
the
we
speed?
assume that we should not hit that fellow now.
No, no, no. I'm saying the Ferrari car goes in a speed way faster than the scooter, right?
Right.
So when the Ferrari cars are going, the turbulence was created, right? So because of that,
What will be the effect if one scooter fellow is also traveling along with you or going in front of you? What will happen?
uh,
You need to slow down, right?
okay, but
Everyone
it's
is
a race.
uh, what
It's
happens,
a
sir?
racetrack, right?
Sorry?
It's a racetrack, right? We can.
Yes, obviously, scooter can't go like 240, 280 like Ferrari, right? So they
No.
will maximum 100 only. So he is occupying one track or half of the track. So obviously, whenever people, cars crossing the scooter, they have to slow down a bit to ensure he is also safe and they are also safe. Like so, knowingly or unknowingly, there will be people are slowing down when they are crossing the scooter. Will you all agree that or not?
Yes. Yes.
Okay, that is interference. So if someone is, if in the racetrack everyone is Ferrari, absolutely no problem. We can go on. Suddenly one cycle is coming and one sudden one fellow is started walking in that one. He will interfere the entire system there, collapse the system.
Yeah.
Everyone will get irritated. As usual, when we are traveling the road, if in US you know that in some cases one way road only. If that fellow travels in 40 miles and you are in 60 miles, in US you can't say, but in India you can harm them, irritate them, yell at them. You can do
Yeah.
it, but US no other option. You have to follow him.
Yeah. Yeah.
You are slowing down yourself. You can't push that fellow to go faster. That is
Yeah.
the difference. The
Okay.
you will encounter so many interferences there.
Okay.
That is why we introduce in the windowing. So in the windowing, how instead of tick to one to one, what we are doing it, where we start with five. If the path is very worst, then we will gradually reduce the windowing. If the path is good, no packet losses experience, we will gradually increasing the window. Increasing the window means what it is now. You are sending
Like
eight packets. Yes.
acknowledging for 10 packets.
Yes, 10
One
packets,
packet.
8 packets, like that.
Yeah.
Decreasing the windowing means slowly going down to 3 or 2 or 1, like that.
Okay.
Okay. Harish, are we good?
Yes, Surendran. Sorry, yes, I could not able to unblock my mic. Sorry. Yes, yes.
Okay.
Good. At the last, it was a lot of information actually.
Ah,
So
no, you should
yeah,
remember this.
yeah, yeah.
OSI is very
Yeah,
basic.
again, so yeah, yeah.
Next
Okay.
class, 10 minutes, I will ask questions. So before that, I will send you that notes for yesterday, no, today.
Okay.
Shall we stop with transport layer?
Yes.
Yeah. Tomorrow we'll continue on the rest.
Because after that, we are coming into picture. It's all three layers. It's our own layer.
Okay.
All
Okay.
three layers.
Actually, we own a transport layer to physical layer, but more work is involved, more control we have it because TCP UDP dynamically they will automatically they will do their job. But here you need to put your hands in from network layer onwards.
Okay.
So selecting the TCP UDP already decided. Or once you decided, then that's it gone. You will not change it for a quite long time. And then the windowing part. Windowing part, UDP is like a typical our Indian postal system, whether you don't know whether he delivered it or not. You believe that he delivered it. That's it. The same case for SMS, the email. Some emails won't come, but it doesn't mean it won't come. Every email has a. We will see the TTL values. I will show that with an example. Mm.
Okay.
It will be delivered, but it will take its own time.
For UDP?
Yes,
But you said it's a speed one, right?
very good. Speed compared to TCP. Why I said okay, reliability. You can say reliability, but I said it will reach you, but there is no guarantee. Somehow it will reach us. It may take time, but it will reach you. But if you are sending TCP packet and UDP packet same day, UDP will fly just like that. But it's a small packet size is small. It is like a mice. It is like a elephant.
Okay.
Size is also here matter. This fellow follows one defined path like an elephant. Elephant always follow one path. This fellow mice, mice, it will never follow a same path. A very good example. If people are there in Boston, uh, so the same thing. Somehow it reached the destination, but this fellow will do all the rules Ramanujan. Like one movie was there, Onion movie, Vikram was there. He will follow all the rules, then only he will reach the other destination.
Okay.
Okay, then I will stop it. I will send the document to you. So tomorrow I will ask the questions in this one. You need to understand it clearly.
Okay.
Okay.
Okay, so tomorrow we will continue the network. We will finish this till physical because if you will completely forgot it, then we will go back to fiber.
Okay.
Okay. Okay. Okay.
And can you like connect both of them in a similar way? Like it doesn't feel like listening to two topics. Did you
Oh,
get my?
okay. Maybe it is good for me. Good for me in the sense I can pick it up because I have a background in that